Within the Northwest Territories of Canada is an unusual geologic phenomena. Along the shoreline of the Arctic Ocean is a grouping of several plumes of smoke rising from the ground. However, these plumes of smoke are not true wildfires as they have been burning for hundreds of years. Despite their vivid coloration, they are also not fumaroles much like seen at Mount Meager. Rather, they have an origin which is not volcanic in nature since this area hasn't seen any volcanic activity for many millions of years. So, why are these unusual fires burning? Why have they turned the ground shades of red and yellow? This video will discuss this geologic oddity often referred to as the Smoking Hills. The Smoking Hills can be found in the far north of Canada within the sparsely populated Northwest Territories. Specifically, it is found 160 kilometers northwest of the town of Polituque. The name of this town gives a good hint of the area's overall geologic setting as it roughly translates to a place of coal. In this section of the country, the area's geology consists of a number of large coal deposits. The specific coal deposits relevant in the creation of the Smoking Hills originate approximately 80 million years ago. At the time, the Earth was a much warmer place and plants covered the landscape as the climate was 8 degrees Celsius or 14 degrees Fahrenheit warmer than it is today. The area was largely covered in a shallow sea, but also a number of shallow bogs. As these plants in these bogs decomposed, they began to change into a compound known as peat. Over many millions of years, this peat changed into the lowest of the 4 grades of coal called lignite. Thus, today the remnants of this low-grade, largely scattered coal deposit remain in the landscape. This might sound strange, but due to its high sulfur content, lignite can reach a temperature where it spontaneously ignites. A similar process occurs in hay, where temperatures above 130 degrees Fahrenheit lead to a chain reaction which eventually results in the ignition of the material. In this case, an oxidation reaction is ongoing with the lignite, causing oxygen to bind to the carbon in its structure, creating carbon dioxide and carbon monoxide. This reaction creates a quantity of heat as it's an exothermic reaction. At higher temperatures, these reactions occur more easily, creating even more significant quantities of heat. Thus, if lignite is heated to a temperature of above 70 degrees Celsius or 158 degrees Fahrenheit, it reaches a critical point of no return. Increased oxidation occurs, and this runaway reaction eventually results in its ignition. In this cold and remote section of Canada, there are not too many things which could have initially heated the coal to these high temperatures. Two likely culprits for the coal's initial ignition are lightning and tectonic faulting. Either of these likely started these fires, which have been burning for several hundred, potentially several thousand years. Over time, these fires have stained the surrounding sedimentary rock to beautiful shades of red, pink, and white due to long-term exposure to various heavy metals such as iron and elements such as sulfur. Thus, what remains today are a series of incredibly slow-burning coal fires adjacent to highly colorful rock which stands out in the barren tundra. I want to note that similar coal and natural gas fires exist around the planet, such as Yanar, Dag, and Azerbaijan. I hope that you enjoyed this video. If you'd like to request a specific topic, please leave a comment below.